Here are solutions to homework set number 6 for ECE 111. In this homework set, you're looking at solving for the voltages and currents in a circuit. And the trick used is n equations, n unknowns. If I have 6 unknowns, like in this case, if I can write 6 equations for the 6 unknowns, I can solve. With voltage nodes, the idea is to use conservation of current. With conservation of current, if I pick a node like node 1, then the current from the node has to add to 0, so the current left plus the current down plus the current right has to add to 0. So my equations would be first, with the voltage source, the equation is that V0 equals 10. My next equation, V1, is the current left, V1 minus V0 over 30, is this equation, plus V1 over 300, plus V1 minus V2 over 40, that's everyone, equals 0. At node 2, current left, which is V2 minus V1 over 40, plus the current down, V2 over 400, plus the current right, V2 minus V3 over 50 equals 0, and so on. When you're all done, I have 6 equations for 6 unknowns, and a check. To make sure I did these right, there's a couple things you can check on. First, at node 1, all the V1s are positive, everyone else is negative. At node 2, all the V2s are positive, everyone else is negative. Also, the units match. I've got volts equals volts. There's V equals IR, or current is voltage over resistance. So this is amps plus amps plus amps, amps plus amps plus amps. The units all match up, so they're probably the right equation. That kind of helps, because if I have something like this, I know right away there's a mistake, because I have amps plus volts plus amps. That doesn't work. You got to have the same units. So right away I know there's a mistake. I need to divide by resistance to get amps. Once you get your 6 equations, 6 unknowns, I can put that into MATLAB. To do that, I put it in matrix form first, group all the terms, put it in matrix form, and what I like doing is, because the way I wrote it, this first column is times the first element. This is times V0, V1, V2, V3, V4, and V5. I just do that as a note to myself. So like this equation, let's do the first equation right here. Minus 1/30th V0 plus this mess times V1 plus minus 1/40th times V2 is 0. 1/40th times V1 plus this mess times V2 minus 1/50th times V3. That's all those elements. Another way to check is when you're done, it should be symmetric. Because I've got 40 ohms connecting nodes 2 and 1, I've got 40 ohms connecting nodes 1 and 2. So these terms should match. So once I have it in matrix form, solve. And to do that, I put it in MATLAB. And what I did is, this is a big matrix to write. So I just did the first row, second row, third row, fourth row. And actually when I input in MATLAB, I take out the semicolon just to make sure each row is a 1/6 matrix. Once you get them in, actually kind of what I did is I then copied into my solution, deleted all the mistakes, made it look like it was easy. Pack A together, first row, second row, third row, fourth row. Here's your B matrix. And then the voltage is the inverse of A times B. So there's my voltage. Just solve 6 equations, 6 unknowns. To check your answer, you can throw it in Circuit Lab. Build the circuit in Circuit Lab, hit solve, and here's what I get. That's what MATLAB calculated. This is what Circuit Lab calculated. The two should match. So that was the first 3 problems, voltage nodes. The next 3 problems. There are also currents in the circuit. Current loops is another technique. What you do is you define, or count how many windows you have. I've got 5 windows. Define the currents in each window. And I like making all the currents go in the same direction, clockwise. If you do that, there's a pattern. Then around each closed loop, I start from a point, go all the way around the loop. If I wind up where I started, the total voltage drop has to be 0. And the convention I'm going to use is if I hit the minus sign first, I'll subtract. Plus sign first, I'll add. So around loop I1, I go right here. There's minus 10, because I hit the minus sign first, plus this voltage. That's 30 times the current going right, 30 I1, plus this voltage. That's 300 times the current going down. The current going down is I1 minus I2. And I'm back where I started. That equals 0. Around loop I2, I go up. That's 300 times the current going up, I2 minus I1, plus 40 times I2, plus 400 times the current going down, I2 minus I3, and I'm back where I started, equals 0. Likewise for loop 3, 4, and 5, and there's your loop equations. There's a pattern here. Around loop I3, all the I3s are positive, everyone else is negative. Around loop I4, all the I4s are positive, everyone else is negative, and you still have V equals IR. When I add terms, they have to have the same unit. So I've got volts plus volts plus volts. That works. Volts plus volts plus volts. If I did something like this, I know something's wrong because I have volts plus ohms. Those don't add. Or if I did this, I'd have volts plus amps. Again, that doesn't make any sense. It's got to be volts plus volts plus volts. Once I get my 5 equations, 5 unknowns, group the terms, put it in matrix form. Again, in matrix form, the first column is times I1, then I2, I3, I4, I5. So this first equation is 330 I1 minus 300 I2 equals 10. The second equation, minus 300 I1 plus 740 I2 minus 400 I3 is 0, and so on. Once I get it in matrix form, throw it in MATLAB. So here's the first row, second row, third row, fourth row, fifth row, pack it all together. There's my B matrix. The current then is the inverse of A times B. In CircuitLab, it gives units of milliamps, so I just displayed I times 1,000. That gives units of milliamps. If I build it in CircuitLab, I get the same answer. So here's 66.4, 66.4, 39.7067, 39.71. CircuitLab rounds it to 2 decimal points. MATLAB rounds it to 4, but same answer. So that's homework set number 6 for ECE 111. And the idea in this class is this is a very common trick we use in electrical computer engineering, n equations, n unknowns. If I have a problem to solve, if I can convert it to n equations, n unknowns, I can solve it. And that's kind of what you do in Circuits 1. This is a technique, current loops, voltage nodes. Use those techniques, they always apply. And what I do on tests is, let's go back to voltage nodes. If you had this circuit and I want to solve for it, you might be able to memorize it. What I'll do on a test is I'll say, now solve for this circuit, but that's 80 ohms. If you memorize circuits, you're out of luck. I didn't memorize this circuit. Voltage nodes is not a problem. At this node, I now have 4 currents, current left, down, right, and up. At this node, I have 3 terms now, left, down, and up. If you memorize the techniques or learn the techniques always apply. And that's kind of what we do on tests. If you master the techniques, you'll get 100 on the test. If you're trying to memorize your way through, you're going to struggle. But anyway, that's homework set number 6 for ECE 111.